This video is about working out a formula for the area of a segment of a circle. Okay, so, okay. Area of a segment. So let's draw a circle. And remember, a segment, okay, is this shaded portion. Okay. Okay, so now, let's call this A. Okay, so radius R, theta, radians at the center. Okay, so if I'm looking for this area, okay, just think for a moment, pause the video and think about how would you go about finding that? Okay, so the area of a segment, so isn't that the area of the whole sector minus the area of this triangle? Yeah, so area of segment equals area of sector minus area of triangle, yeah? Okay, so then that is, remember the area of a sector is 1 on 2 r squared theta, so 1 on 2 r squared theta minus the area of the sector is 1 on 2, and that is, if you remember the area formula, yeah, half AB sine C, so half the side lengths multiplied together times sine the angle between them. So in this case, it's going to be 1 on 2, so AB sine C, yeah? So R times R times R times sine the included angle, theta, which is 1 on 2 r squared theta minus 1 on 2 r squared sine theta, right? And you can take a common factor. Yeah, notice 1 on 2 r squared is in both terms. So that's 1 on 2 r squared theta minus sine theta. And remember, theta is in radians, okay? So, of segment. Therefore, okay, where theta is in radians, must be measured in radians. Okay, let's do an example now. Okay. All right, so an arc AB subtends an angle, so an arc AB subtends an angle of 126 degrees and 52 minutes. All right. Okay. At the center of a circle with radius 6 centimeters. Okay, so always do a diagram. It just helps you to see what's going on instead of trying to imagine it. Center of a circle with radius 6 centimeters. Okay, we need to calculate a few things. So calculate. Okay, the length of the arc, correct to 1 decimal place. The area of the sector and the area of the minor segment cut by the chord AB. Okay, so let's start with A. The length of the arc AB. Okay, and let's do our circle. All right, so here we are. The angle is 126 degrees, 52 minutes. Okay, 126, 52. And our radius is 6 centimeters. Yep, 6 centimeters. Okay, so same thing. This angle is in degrees. In order to use, so to find the length of the arc AB, okay, we need to have that angle in radians. So L equals theta, okay, and then L equals the radius, which is 6 times. So theta, and again, you have got to change that to a decimal. So that's 126. So you do 126 degrees, 52 minutes, and you press the degrees, minutes, seconds, and you get 126.866 ... Okay, now then, so that's still in degrees, and then you multiply that by pi on 180 to change it to radians. Okay, so then the arc length is 13.284, so the arc length is approximately 13.3 centimeters. Okay, so that's part A. Now part B, we want the area of the sector. So let's have a look. Okay, let's work here. The area of sector AOB. Okay, so area equals half r squared theta, and that's easy. So the area is 1 on 2 times 6 squared times 126 point. It's better to have it like this so you get an accurate answer. Okay, don't round off until the end, and then convert that, which is in degrees, to radians. Okay, and so the area of the sector is 39.85 ... square centimeters, which is approximately 40 square centimeters. Okay, now the area of the minor segment. Okay, so minor because so the minor segment, because this part of the circle is bigger, this is called a minor segment, yeah, because 126 degrees is less than half of 360 degrees, yeah, so that makes it a minor segment. Okay, so area of minor segment, so that's part C. Okay, so the area of the minor segment is, remember, 1 on 2 r squared, theta minus sine theta, where theta is in radians. Look, you could put the whole thing in your calculator, or might be a bit tedious. So let's work out what 26, so 26, let's have a look, 126, sorry. So A equals 1 over 2 times 6 squared, or 36. Now theta, remember, is 126.666, etc., times pi on 180. I would actually, let's work that out. So 126 degrees, and what was it, 52 minutes, okay, equals that. Let's change it to a decimal, and then, so we're going to multiply that by pi and divide it by 180, yeah? So times shift pi, and then equals, and then divided by 180 equals, and then, so this is, because we started out with this, but obviously in radians that doesn't make sense. So it's 2.214 radians, yeah? You can see the answer there. Okay. So 2 point, let's put a few decimal places, yeah? 21424 dot 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 minus sine 2.2, now 2.214 dot dot dot. Now for this, okay, you must have your calculator in radians to get the right answer. And the way to do that, you change your see how it's got a D now? Most of you should have D on your screen. So if you go shift mode, okay, and number 4 on my calculator is radians, and I choose 4, then I can now use sine 2.2144, etc., 42, and it will give me the right answer. Otherwise, you can put 2.21424 minus sine 126.66, yeah? But for this chapter, it's better to set your calculator now to radians, but be mindful if you forget and use degrees. Be mindful of the change of units. Okay, so then for this, we've got a half times 6 squared, and now my calculator is in radians. I can put 2.21424 minus sine 2.42414, and you should get 25, so the area is equal to 25.4, okay, square centimeters, which is approximately 25 square centimeters. And so that's the area of the minor segment. That's this bit over here, okay?